We are on 1.3 now. So the first section that we learned was we learned how to find the limit by looking at the graph, by looking at the table. Now we're going to look at them analytically. Analytically means we are just going to look at an equation and then solve it from there without any graphing or any table. Okay, so first let's try to find the limit. So it says the limit as x goes to 2 of 4x squared plus 3. Now, anytime you're trying to find a limit, the first thing you should do is just plug it in. So that it has to be your number one way of checking limit, just plug it in, okay? I'm going to teach you a lot of tricks to finding limit when plugging in doesn't work, but plugging it in should be the first thing you do. Only when it doesn't work, then try the tricks, okay? So most important thing, plug it in, because people always learn all the tricks and they want to apply all the tricks all the time and they waste their time. So that is not necessary, just plug it in. So 4 times 2 squared plus 3 is 19, so the limit is 19. Okay, so why does that work? Well, when the function, so remember this part is f of x. When the function is continuous, obviously if it continues, then that point that exists is the limit, right? Because there is no hole, there's no discontinuity. So when it's continuous at that point, that is the answer. So I'm going to give you two tricks or 2 hints. First, if the function is continuous, just substitute. Okay, you don't have to write it exactly, just know it and then or like paraphrase it. When the function is continuous, just substitute. It will always work. When you cannot tell if it's continuous or not, still substitute. You might get lucky and it will actually work. Okay, so anyways, no matter what you do, just plug it in. That has to be the first thing you do. Direct substitution. Now, when it doesn't work, or you cannot tell, exactly what to do, there are some limit rules. The first one is called the scalar multiple. Do you guys remember what scalar means? Mm-hmm. What does it mean?
It's like a number that, say it's like 3 and then everything in parentheses. It makes one number bigger.
Yeah, so scalar is just a number that you're multiplying to. Okay, so scalar multiple. So for example, limit as x goes to c of k, and k is the scalar times the function f of x. And let's say you cannot figure out what the limit is. What you can do is you can take k out. So k is just a scalar, so you can take it out of the limit and then find the limit by itself, and then that will work. So that is basically what you did on the warm-up. If you got 15 on that one answer, the question was limit as x goes to 2 plus of 3 times f of x. What you did was you essentially took that 3 out, and then you found the limit and you multiplied by 3. That's exactly what you did. All right, so that is scalar multiple. The second rule is sum or difference. So sum or difference means if you have a limit as x goes to c, and let's say you have 2 functions. One of them is a f of x, the other one is a g of x, and sometimes you add or sometimes you subtract. It doesn't really matter whether you add or subtract. And let's say you cannot figure out what the limit is. You could split them up into 2 limits. So you could split them so it's f of x and then plus or minus depending on the question, and then x goes to c of g of x. So essentially it's saying that you can break the limit of 2 functions into 2 limits of 2 functions. All right, pretty intuitive. Next one, product. So if you have a limit of as x goes to c of f of x times g of x, and you cannot figure that out, you don't know what it is, you can split it. So it's the limit as x goes to c of f of x times the limit as x goes to c of g of x. Okay, quotient is similar. So if you have limit as x goes to c of f of x divided by g of x, then you can find the limit by just splitting them into two limits dividing by each other. But you need to make sure that limit as x goes to c of g of x is not 0, because you cannot divide by 0. So all this is pretty intuitive. You probably would have thought about doing the same thing, but we're just writing it down so that you have something for reference later. Okay, power is the same thing. So if you have limit as x goes to c of f of x, and let's say that this function is raised to the nth power, and sometimes when it's raised to some kind of power, it makes us a little bit anxious, like I'm not sure how to solve this. So what you can do is you can take that power out and then find the limit of f of x by itself, and then raise the whole thing to that power later. And exponents are related to your roots, right? Because roots are basically fractional exponents. So the same thing, if you have the limit as x goes to c of the nth root of f of x, and that kind of scares you because you're like, I'm not sure how to take limits of roots, you can also pull that out and then find the limit first before you take the root. Okay, pretty intuitive. Now we're going to solve. For the most part, when you actually just have numbers like equations like that, you probably will never even think about this. You would just apply it like without thinking. But the hard ones are the ones where they give you a graph, which is what I'm going to do next, and then have you find the limit because it's not intuitive. Okay, so find the limit using this graph. Let's just do the first one first.
Do we just draw that on our thing?
It's up to you. You're taking notes, so you can do whatever you want.
Oh, are you going to do note checks or something like that?
No, I'm not going to do note checks. Okay, so let's have you try this first one. Limit as x goes to -2 of f of x plus 5g of x. So look at the graph and try to do this one. All right, let's just check the answer first before I show you how to solve it. What is the answer? -4. Okay, so let's kind of look at it by breaking this problem down. So limit rule says if we have a function plus another function, we can split it into two limits. So this is the limit as x goes to -2 of f of x plus limit as x goes to -2 of 5g of x. And then we said scalar multiple is a rule in limit, so we can actually pull out that 5. So limit as x goes to -2 of f of x plus 5 limit as x goes to -2 of g of x. So now it's just a matter of trying to find the limit of those functions at those numbers. Okay, so limit as x goes to -2 of f of x. So let's look at f. F is the blue graph. Limit as x goes to -2 of f is 1. So that part is just 1. And then plus 5 times the limit of as x goes to -2 of g of x. So as x is going to -2 on g, g is going to be -1. So that's going to be -1. So this turns out to be -4. So that's how you solve it. Okay, let's try the second one. Number 2. Talk to your partner if you're stuck. Limit as x goes to 1 of f times g. All right, number 2, what do you guys think? What's the limit? Correct, does not exist. If one of them does not exist, you cannot multiply them together and get a limit, so it does not exist. Okay, number 3, limit as x goes to 3 of f divided by g. All right, number 3, what's the answer?
0.
Good, 0. Okay, let's try other ones. Okay. Let's have you guys practice 1 and 2. Okay, so the first one is 39. The second one is minus 1 over 11. Okay, easy. So they're all continuous at that point. Okay, so number 2 is not a continuous function, right? Because there's a denominator issue. But it doesn't really matter. It's continuous at -2. Okay, as long as the limit we are looking for is continuous at that point, then it doesn't matter. Okay, let's look at this one. This one's really tricky, actually. It's not tricky when I show you, but Wednesday when you come in, I will give you a warm-up that is very tricky. Okay, so when you are composing, I hope you remember what composing means from last year. You're going to put one function inside the other. Okay, so if f and g are functions such that, so let's say that limit as x goes to c of g of x is L. So when x is going to c of g, g is going to L, so y is going to L. So, yeah. And limit as x goes to L of f of x is equal to f of L. What does that mean? So when x is going to c in g, y goes to L. Now when x goes to L in f of x, it goes to f goes to f of L. Then limit as x goes to c of f of g of x. So basically we're putting g inside f now. Is equal to taking f and then putting it outside the function. Like that. And that's equal to f of L. So what does that actually mean? Okay, well, write it down first and I'll show you what it means. Okay, so what does this actually mean? So let's just look at this one. This is kind of our final one, right? So we want to look at it and say, what is it talking about? So the limit as x goes to c of this function that is composed, well, where does x go to? Or where does x apply to? Well, x is going to apply to g first, right? Because that's the inside function, right? So then when x is going to c, we care about g first. Well, where is g going to when x goes to c? L, right? So essentially, if this part is L, this g becomes L, I am actually just changing this whole limit thing into this, right? Because g is now gone, because I already evaluated it, right? So when x is going to c, look at the inside function, because x only applies to the innermost function. That became a L. If that became a L, I already evaluated it. Like, I figured out what that number is. So then this is now the new x. Okay, I have two functions, right? Dropping this x into this bucket, and then this bucket goes out into this bucket. Oh, okay, let's draw this. Okay, so x is here. It goes into g, and then g goes inside f, right? X goes into g, what does it become?
L.
L. Now L goes into f, and it becomes f of L. So that's what happens. So when x goes into g, it becomes L. I can change the whole question so that it's just L as the new x. Yes?
Yeah.
Okay, so Zach's like...
Probably not important.
Okay, now this works if the limit actually exists at each one. If the limit doesn't exist, which is what we're going to do tomorrow, then we have to do something very tricky to find the limit. But if the limit does exist at each one on those points, then you just plug it in like that, and then you solve it. Okay, let's look at an example. Using that same exact graph, we're going to compose. Okay, so let's look at number 1. limit as x goes to 2 of f of g of x. Limit as x goes to 2 of f of g of x. Okay, go ahead and try it. The answer is not a whole number. It's not an integer. It's I kind of made it, yeah, so it's kind of a decimal. Sorry about that. Okay, what you guys write for the answer? 1 point something. Yes. Okay, so let's look at this question. So limit as x goes to 2 of f of g of x. So we are going to go to 2 on g first because it's saying drop it into g first. So limit as x goes to 2 of g of x is what we need first. So g of x at 2 is 0, right? So now we are evaluating limit as x goes to 0 of f. So when the function is going to 0 on f, it's about like maybe 1.2. So the answer is around 1.2. Does that make sense?
When x is going to 2 for the f part.
Because remember, your function is dropping the x into g. Once it evaluates what that number is, then it goes to f. 2 does not go into f. Okay, next one. Let's go backwards or the other way around. Limit as x goes to -2 of g of f of x. All right, this one is really tricky. What do you guys think the answer is? No. The answer is -2.
Yeah, let's go.
Okay, why? Okay, this is very, very tricky, which is on the warm-up on Wednesday. Okay, so first of all, if you just apply the same limit rule as before, it will not work. Because remember, I said it only works if the limit exists on both functions. On f, obviously, there is no limit. You cannot apply the rule. Like the rule doesn't even work anymore. So you have to use something else. Okay, so for example, okay, limit as x goes to -2 of this function. So we have to find the limit as f goes to -2. So as f goes to -2, we can see the limit is 1. Now, if I plug in 1 as the new x into g, so when x is going to 1, you can see that it splits. So you would automatically say does not exist. But it's not true because the limit as x goes to, this is what we're going to talk about soon. We haven't really covered this yet, but you'll see. Okay, so limit as x goes to -2. Now, we're going to -2. We said the limit exists if we are going to the same number from both sides, right? So then we have to look at the left-hand side, and then we have to look at the right-hand side. Okay, which is okay. I mean, both of them are going to give you the same number. But this is the tricky part. Which, if the number is farther from -2, so the question is, when it's going to -2 from both sides, we're approaching 1. We're approaching 1 from lower than 1 or higher than 1? Lower than 1. So we're basically like numbers that's a little lower than 1 until 1, right? So when we're trying to approach g at 1, we're not looking at 1. We're looking from lower than 1.
Or you could just do the thing with the, remember?
We're going from so when we're going to -2, the y is going from the lower part of 1. So it's getting to 1 from small to large. So when we're going to 1 on g, we have to go from small to large.
Okay.
So then it's this limit. We are not looking here because we never went to 1
We never went above.
from the more positive side.
Do the thing, remember, like, because now it's just g to 1. It's not like a limit.
Right.
So we're looking for like an exact point, remember? Wait, what if it
No,
was going from
we are not
Yeah.
taking the limit part out. Hold on. Yes.
What if one side came from above and one side came from under?
Then does not exist. Yeah. Correct. Question.
Okay, so if it came from above, then it would be -1.
Yes. Question. Zach,
Just
question?
write that down in the notes, because I'd like to.
Yes.
So if the graph was coming from above 1, would that mean we're coming from the other side?
You mean like if f like it looked like that?
Yeah.
Then the limit does not exist because one side of -2 is coming to 1 from more higher than 1 or more the positive of 1. And then this side is coming from the lower part of 1. So then when you're looking at this G graph, you're looking from this side and this side at the same time, so it does not exist.
Okay. And if they were both up, it'd be -1.
Right, correct. Yes.
So, which side of GFX are you looking at?
Which side of g of x?
The small
For this question, we're coming from the bottom of 1. So we're going basically saying like less smaller than 1 to 1. So smaller than 1 to 1. 1 is here, so coming from this way that we're following this part of g.
My head hurts.
So yes, this is really tricky. Okay,
Please get the other ones.
let's do the easy stuff now.
Yeah.
Huh? Sorry.
Yeah.
All right, now how do we actually solve these limits without tricky stuff? Okay, so we're looking at just one function at a time. Let's look at this function. So the first thing you do with any limit is you do what? Plug it in. Okay, yeah, so let's plug it in and see what happens. -3 squared minus 3 minus 6 over -3 plus 3. End up 0 over 0. 0 over 0. That's a special thing in calculus. It means it's possible, but do it a different way. Okay, so what we're going to do is we are going to factor and simplify. Now, when you do, yes?
Is this only for when the top and the bottom are both 0?
Yes, correct. Only when the top and bottom are both zeros. So in this case, what we're going to do is we're going to factor and simplify. So when you do this, you have to keep the limit sign the whole time.
Oh, I hate
Is this still with me?
Yeah.
Can you put your calculator away? Okay, so that's going to be x plus 3 times x minus 2 over x plus 3. And what we can see is that this factor cancels. Keep the limit because you didn't substitute yet. You always have to keep it until you substitute. So limit as x goes to -3 of x minus 2. Now you substitute, so the answer is -5. All right, let's have you guys practice. Okay, so only when you have a 0 over 0, then you do something like this. Okay, so let's have you practice with one of them. Let's try this one. Okay, so hopefully you got to the correct answer. The answer is 5/8. Good? Okay, let's try another one. This is, not hard stuff. It's just kind of like algebra review almost. Let's try this one here. Okay, if you put in 3 right now, you will get 0 over 0. So this is just a practice of like, can you simplify this fraction? Okay, try it. All right, let's make sure we can do this. This is an important skill. Okay, limit as x goes to 3 of 3 minus x over 3x over x minus 3. So you can see that x minus 3 is probably going to cancel, but it's just in the wrong order, so we're going to have to change that direction. So take the negative out, x minus 3 over, and hopefully you remember that two denominators will combine. So that is a 3x times x minus 3. So that cancels, so we have a limit as x goes to 3 of minus 1 over 3x, so the answer is -1/9. Okay, so, skills you gotta remember. Next part, and also this is a skill from last year. When you have a 0 over 0, that looks like this. You have a radical. Okay, when you have a radical, you're going to have to rationalize by multiplying by the conjugate. Okay, well, we have a radical in the numerator. What is the conjugate?
Square root of x plus 1 plus 1.
Yes. Okay, and then make sure you do that to top and bottom. Okay, remember on the top you have an a minus b times a plus b, so that's an a squared minus b squared. Use that shortcut instead of doing crazy things. So that's a minus 1 over x times, make sure you put parentheses. If you don't, it's going to be very crazy. Okay, so that 1 cancels, and you can see x will cancel as well. So you basically have a limit as x goes to 0 of 1 over square root of x plus 1 plus 1. And when x goes to 0, it's just 1/2. Okay, so this is just, make sure you multiply by the conjugate. Which part?
Never mind. I mean,
Okay, let's do one more problem and we call it a day. You guys got it? Copied everything down?
No.
Okay, let's do one. This one.
wait.
Ooh, I'll show you. Okay, then multiply by the conjugate. No, 1 minus 1 is 0, but it's still x. X and x cancel, so it's just 1.
I missed number really kids.
Wait.
First one? You got it.
Oh my gosh, why can't I do that?
Okay, what's the answer? 1/4? I think. I think it's. Oh, 1/4. Wait a minute. 1/4. Multiply the conjugate. So it's a plus 2 in the denominator.